Well, I'm Ramon Bosch. I am the CTO and co-founder at Nuclia, and we are an organization that tries to and fixes the AI search as a service with generative AI. At the beginning, when we were starting to develop the first prototypes of Nuclia, we realized that we needed an event source system that provides transactionability and commit log across all the activity, as we are processing engine that it's processing all kind of data, and we needed to have a way to have this transactionability in commit log. At that moment, we were evaluating multiple solutions on the open source side of this technology, and it was early stage Stan, a streaming service from NATS, and there was already some papers writing about Jetstream, and at that moment we were a really small team, so we needed to focus on a solution that was able to be operated and managed by us, and that we would feel comfortable delivering this on our cloud and in our on-premise installations. So we choose NATS for its agility and its easy usage point of view at the operational level. Our Nuclia architecture is fully distributed. We have multiple processing areas in different cloud providers. Right now we are supporting Amazon, Google Cloud, and on-premise deployments. That makes us really special about how we are dealing with these processing zones. And we also, at the same time, have our own database that we built from scratch, half in Rust, half in Python, to provide a specific database focused on search on top of AI with generative AI. It's not a vector database only. It's not a full text search database. It's not a knowledge graph database. It's a database just focused for Gen AI. These two concepts, our processing zones and the database, requires both of them an event source to work properly and to scale horizontally. So like an enterprise bus. In that case, the two different streaming pipelines are completely separated. One is to provide transactionability on top of the database, so we can make sure that nothing is written and and stored in proper order that the user is expecting. And the other one is to provide the availability to define the different pipelines of processing at different speed, different kinds of accounts, different priorities. So our deployment strategy for NATS was to build two different clusters at each processing zone, one for the database and one for the processing pipeline. Well, the architecture of NATS it makes it really simple to adapt to your use case, because it's a really low level technology that works really well, doing the main use case of transactionability and commit log in our case. And this allowed us, for example, to be schema-less on the kind of the messages that we are sending, and to provide more validation of a schema at the client side, which allows us to send proto-buffers, for example, inside of the stream. The creation of consumers, the creation of streams via the API makes us really easy to create everything and have proper rollout strategies, so we can deploy a full new cluster without any operational extra cost. Everything is configured via software with our own operators, and the fact that NATS is super simple makes that as a liability to deliver this kind of features on the software architecture. The Nuclia, it's mostly based in two main languages: Rust for everything that requires performance and requires that it's really close to the CPU and the hardware. Like, for example, our database, the indexes, and some of the processing pipeline components are written in Rust. And then all the glue software, all the different pieces, APIs, different database connectors are mostly written in Python, which makes really an agile strategy for scaling and growing fast. I would say that NATS delivers a really good and fresh feeling when you are developing a big architecture and a distributed architecture, because the entry level, it's really low, so you can easily start focusing on the value proposition and not the enterprise bus. So it was a really a good feeling, the first steps of developing the platform with NATS.